Hello, Assalamualaikum warahmatullahi wabarakatuh, my dear students. Madam Ruby here, logging in for lesson 76, Synthesis of Carbonyl Compounds. We are entering chapter 9 now. I remember when you were doing experiment 6 in the lab, you struggled to understand the structures of aldehydes and ketones. So today we are going to draw the structure and name the carbonyl compounds for aldehyde and for ketone. And we are going to learn how to synthesize them using reactions of oxidation from alcohol, ozonolysis from alkenes, and Friedel-Craft acylation to produce aromatic aldehydes. In the grouping assignment, you have to find a verse regarding a fruit, right? Some found figs from Wattini was Zaitun. Japanese scientists discovered that figs has benzaldehyde that, when extracted from figs and used, it is proven to be effective in fighting carcinogens. This is a hadith narrated by Abu Darda. If I were to tell you of a fruit that has been sent from paradise, it would be fig. Fruits of paradise are without pits. Eat the fig, as it is a cure for hemorrhoids and gout. This is the verse I have recited previously. It's from the Quran, chapter 95, sentence 1 and 2. One of the chapters that we memorized since we were a child. And today we use it during our Tarawih for Ramadan. Aldehyde can be found as active compound in a lot of food and herbs that is available around us. For example, you know what this is. We use it a lot in cooking. Cymbopogon citrullus. Its Latin name is that one. And then the right one here, it's also the thing that we use in our curry, cinnamaldehyde. And the lower part here, this is what we use to bake our eat cookies, prunos dulcis. And this one we don't use much because cheese is expensive. Penicillium roquefort. Aldehyde and ketones are basically compound that contains carbonyl group. Aldehyde contains a hydrogen atom bonded to the carbonyl carbon, whereas ketone has two alkyl groups attached to the carbonyl carbon. That is the difference between aldehyde and ketone. For ketone, it can also be an aromatic ring. An aromatic ring attached to the carbonyl carbon, this is also considered as ketone. In your course book table 9.1 shown to you is 4 simple aldehyde and ketones with their IUPAC nomenclature and common names. So as you can see, for aldehyde, we have all the compounds having a suffix al. Methanal, ethanal, propanal, and butanal, depending on how many carbons are there in the compound. For ketone, we have suffix on. Propanon would have the carbonyl carbon in the middle at carbon number 2. 2-butanon is having the carbonyl carbon as carbon number 2. So we don't have to put 2 here because it's not going to be 3. If we put the carbonyl carbon here, it's also going to be 2. So writing down butanon is enough for this compound. But for this third ketone, 2-pentanone, we have to put number 2 because it can be 3-pentanone, looking at where the carbonyl carbon would be positioned. Here are the two reactions that we have learned previously in order to produce aldehyde. The first one is the oxidation of a primary alcohol using PCC CH2Cl2. We are going to produce aldehyde. Why? Because PCC is a weak oxidizing agent. If we use KMnO4, we are not going to get aldehyde. Instead, it's going to be oxidized further into carboxylic acid. The second reaction is the ozonolysis of alkene, which will break the double bond into two compounds. And if we have a hydrogen attached to the restricted carbon, we are going to get an aldehyde. Now, how to prepare ketone? We have learned a lot of reactions to prepare ketone previously in several chapters, chapter 5, 6, 7, and 8. So now in chapter 9, we're going to do revisions on those reactions. Secondary alcohol will be oxidized using KMnO4 potassium permanganate in acidic environment and heat, or PCC-CH2Cl2 to produce ketones. Alkenes also is going to undergo ozonolysis if at the restricted carbon we have an alkyl group. Both places we are going to get ketones as well. And the third one is Friedel-Craft acylation, where we're going to react a benzene ring with an acyl chloride in the presence of AlCl3 and heat. We are going to form an aromatic ketone. Let's open your page 306 and then write the answers for example 9.1. For the first reaction, let's do oxidation on ethanol using PCC and CH2Cl2. We are going to get an ethanol. For the second reaction, this is 2-methylpropanol. We are going to use PCC and CH2Cl2 also. And then we are going to get 2-methylpropanol. For our third reaction, let's look at the structure of this alcohol. This is a secondary alcohol. So we're going to use pyridinium chlorochromate in anhydrous media, CH2Cl2, and we are going to get propanone, a ketone. For the fourth reaction, we're going to use also a secondary alcohol. This time, we are using a strong oxidizing agent, potassium dichromate in acidic environment and heat. The product would be 3-methyl-2-butanone. Here is a little bit of revision on chapter 8. This shown to you is a tertiary alcohol. Tertiary alcohol has no hydrogen attached to the hydroxy carbon. Therefore, it cannot be oxidized. There would be no reaction. Okay, next page. Let's revise ozonolysis of alkenes. Alkene, when ozonolized, it will form aldehyde and ketone depending on what group or what atom attached to the restricted carbon. If we have a hydrogen atom, we are going to get an aldehyde. But if we have both alkyl group attached to one restricted carbon, we are going to get a ketone. So what we are going to do for question number 1 here is we need to redraw the condensed structure of this alkene to show what group or atom that is attached to the restricted carbon. So the second carbon here is this one. So attached to it is a hydrogen atom, this one, and also a methyl group, this one. Okay, so the third carbon here is another restricted carbon, and you will see here this is the hydrogen atom, and then this group is an ethyl group, an alkyl group. So we are going to break this double bond, and we are going to produce an ethanol and a propanol. Okay, let's do question number 2. Look at the alkene. By now, I think you can see that we are going to break this double bond, making a cleavage over there. And then the restricted carbon here would have one methyl group and one ethyl group. So this would be a ketone over here. And then the restricted carbon number 2 on the right here would have one hydrogen atom and one ethyl group. It is going to form an aldehyde here on the right. So the product would be a butanol and a propanol. Let's do question number 3 now. It's a cyclic compound. This is interesting. We need to number the carbon so that we can draw the product clearly after this. Okay, where do we want to start numbering this compound? Okay, maybe from here. Carbon number 1 is attached to carbon number 2. So number 3 is here, number 4 is here, number 5 is here. So basically, this is a 4-methyl cyclopentene, right? Okay, so we're going to break the double bond over there, and we are going to form a carbonyl carbon out of carbon number 1 and carbon number 2. So let's just draw carbon number 1 over here, and then this oxygen would be there, and then carbon number 1 is attached to carbon number 5 here. This is carbon number 5, carbon number 1, and carbon number 5 is attached to carbon number 4, and then this is the substituent attached at carbon number 4. And then at carbon number 4 will be attached carbon number 3, and at carbon number 3 is the second carbonyl carbon that would have the oxygen there. Now we have to fill in all the hydrogens. Okay, this would have one hydrogen. This is an aldehyde, and then here we have 2, and then here we would have 1, here we would have 2 also, and here we have to have 1. Okay, so this is dial 1. Okay, let me change the color. 1, 2, 3, 4, 5. Okay, we have a pentan, a 1,5-diol, and then you have a substituted carbon number 3. So 3-methyl. This is the name of the product that we have formed. Okay, let's do question number 4. What's the reactant? Another cyclic compound, and this time it has 2 double bonds. So we need to break off these 2 bonds, and therefore we're going to get 2 products. So let's number the compound from here. 1, 2, 3, 4, 5, 6. So carbon number 2 would be attached to carbon number 3. Okay, carbon number 2 is a carbonyl carbon, so this is carbon number 3, and then it will be attached to carbon number 4. Carbon number 4 is also a carbonyl carbon. So basically, the left side would produce aldehyde. You see? Aldehyde. So the aldehyde is called 1, 2, 3. We have a propan, 1, 3-diol. Okay, let's go back to the right part. Carbon number 1 has a methyl group attached to it. So this is a CH3 there. Carbon number 1 is also attached to carbon number 6, and it is also attached to carbon number 5, which is a carbonyl compound. So the carbonyl compound on the left side would be an aldehyde, but on the right side, carbon number 1 here is basically a ketone. This carbon is a ketone. Aldehyde has a higher priority compared to ketone. So this carbon is going to be its substituent. Starting from left, the priority of group 1, 1, 2, 3, 4. This is basically a butanal. At carbon number 3, we have an oxo, 3-oxobutanal. So the ozonolysis of this, we forgot to name this alkene. Okay, this is 1-methyl cyclohex hex 1 and 4-diene. That's the name of the alkene. It's going to produce propan 1,3-diol and 3-oxobutanal. Right, the third reaction to produce carbonyl compound is Friedel-Craft acylation. So let's do example 9.3. As you can see, we have a benzene ring and an acyl chloride over here. This acyl chloride, we are going to remove the Cl, and however R we're having attached to the carbonyl group here is going to be attached together to form the ketone. So what is the answer? This is the benzene ring. It is attached to the carbonyl group, and all the R here is going to be attached here. What's the name for this compound? 3-methyl. Where is the methyl? Here. 3-methyl, because this is carbon number 1. 1, 2, 3, 4. It's a butanone. So at carbon number 1, we have a phenyl. At carbon number 3, we have a methyl. Let's do question number 2. We have a benzene ring reacting with a cyclohexane carbonyl chloride. This is the IUPAC name for the reactant we're using. Together with the Lewis acid and heat, we are going to get a cyclohexyl phenylmethanone. Methanone is here, the carbonyl group having only 1 carbon. At methanone, attached is a cyclohexyl and a phenyl. Okay, the third reaction, let's do one example using an acid anhydride. Acid anhydride is a symmetrical compound like this. As you can see, we're going to use a benzene ring. A benzene ring will be attached to only this side, either one of the side here. So we are going to get a phenylethanone. We're going to get this side. This is C double bond O, the carbonyl group here. And this is the methyl attached here. And the benzene ring will be coming attached here. So phenylethanone is going to produce when benzene ring is reacted with an acid anhydride. Thank you very much for watching. It's going to become a smooth ride for you after this. So please fill in your mind maps. It would be an easy way for you to remember all the reactions. Let's proceed to the next lesson. Bye. Assalamualaikum.